In 2016, the Camille and Henry Dreyfus Foundation asked each of its recent Teacher Scholar Award recipients to produce a short video describing their research for a lay audience. The foundation then asked two veteran science television producers, Gino Del Guercio and Stephen Lyons, to critique the videos at the Teacher Scholar Symposium, offering constructive suggestions to current and future award recipients. This video includes excerpts from their talks.
One of the things you want to think about, the most important step of all, is what are your goals? What are you trying to achieve with your video? There are basically three different goals that you can achieve. One is to entertain, but more likely you are trying to inform. You're scientists, you've got research, you've got maybe opinions that you're trying to get across, and you're trying to somehow communicate it to inform an audience. And the third thing that is often overlooked, but which is very powerful, is inspiration. And when I teach at BU, I teach a graduate course at BU, and oftentimes my students say to me, well, I saw this documentary on National Geographic or PBS on this subject when I was 12 years old, and ever since I've been fascinated with the subject. So you can inspire people to change their careers, to change their lives, to become involved in politics or anything. And what I would say is that in your goals, you probably want to try to achieve some of each. The entertainment factor will allow you to reach a broader audience. The information, obviously, is what you're trying to get across. But the inspiration is equally important because ultimately you want to change people's behavior in their lives. So I would submit that effective communications, it's a combination of the information and the audience. And that's the second thing that people don't think about. Who is your audience? It can be as broad as you want, can be as narrow as you want, but unless you really have a good sense of who your audience is, you're not going to effectively communicate. So maybe you've got a new chemical technique that you're working on, or a new discovery, or something like that, and you produce a little video about that. It can be very, very effective and perfectly worthwhile. You don't have to assume, you don't have to expect that you're going to get an enormous number of hits. If you get a very small number of hits, but those hits are very significant, then you've achieved your goals, and that's a good thing. The first 3 seconds of your video is really, really important. One of the things that a lot of you did was you introduced yourself. The first thing you said, my name is blah, 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 I teach blah, blah, blah. That's not particularly interesting unless you're really famous. Save that for later. You want to get right in there and you want to hit them with something that's really interesting, either something visually that's really interesting or a question that's really interesting. How do you suck them in, keep them going? So think about the first 3 seconds. It's really important. The other thing that's important is real-life applications. Steve and I learned this when we were print journalists. Our editors were always saying to us, well, how does this relate to the viewer or the reader? Why should the reader be interested in this? How is it affecting their lives? If you can include something, especially in the very beginning, that relates directly to their lives in one way or another, either helps them or gives them more information, they can do something, or solves a problem that they're looking for, that's going to keep them watching. Another thing is common ground. If you can have something in there that they can relate to, then they don't feel lost in this sea of new information. So you can have new information in there, but you have to have information that they also understand in order for them to relate to that, and at least they feel like there's something to hold on to when you're showing them new stuff. Raise questions. Questions are great. Constantly raise and answer questions as you go through the video. It keeps people watching, especially if you have a big question that you're going to indicate that you're going to answer it in the end. You're going to tell them the final answer in the end. That's the secret to all fictional movies, right? You stay with the movie because you want to see what happens to the hero at the end. You want to see if they, overcome their final challenge. So try to create these questions that you want to answer, maybe a big one in the end with a bunch of little ones in the middle. Finally, sometimes there's no application at all, right? This is so arcane that it's just beyond everybody else. But there's a reason you're fascinated by it. And if you can somehow convey your fascination with that subject, you might actually have a chance at convincing other people that the subject is interesting as well. So here are some of the videos I want to talk about in a second.
The research in my lab focuses on metabolism. Most of us have probably thought about metabolism before in the context of diet. But the way we think about metabolism in my lab is analogous to sort of like a map, like Google Maps. For example, if we were trying to go from one destination to another, say the university to the airport, you might put in that in Google Maps and hit go, and it would give you one set of directions for going from one location to the other.
Hits all the marks, right? Metabolism. Well, I know about metabolism. I eat food, and it makes me run, so I know about metabolism. And Google, I know about Google. So it's like, okay, he's already talked about two things that I understand. And now I'm sort of set, and I can watch it some more, and I can hold on to those concepts for a while, even though this gets a little more obscure as we go on.
In 1.5 hours, enough solar energy hits the Earth's surface to power human civilization for an entire year. However, there are remaining technological barriers to its widespread adoption. One is cost. The Department of Energy projects that we'll have to decrease the cost of solar energy from its current 10 cents per kilowatt hour to 3 cents per kilowatt hour by 2020 to be competitive with conventional energy sources. If
you actually go on YouTube, there are a number of very successful science sites. The Green Brothers, I don't know if anyone knows the Green Brothers. They have millions and millions of viewers. It's the same style, very fast, lots of information, but she's talking about solar energy, subjects that I might be interested in. I'm going to watch this a little longer. And the difference between what we generally do, Steve and I generally do, which is broadcast journalism, where you can't generally roll back and say, oh, I didn't get that, I'm going to watch that again. For YouTube, you can. So if it's interesting and it's going along and the energy is captivating and it's like I'm getting a lot of info, I'm not getting bored here, then I don't quite understand it. I can watch it again. I can roll it back. I can see what she's talking about again. So I don't think it's such an issue because it's too fast. And the extra speed and energy actually keeps you entertained and watching.
So when we use the products and electronics that we use every day, we consume a large amount of electricity. Much of that electricity right now comes from coal-fired power plants. These power plants have a long lifetime, something like 40 years. So even if we decided to make a transition into a more carbon neutral or solar or wind power, these power plants are likely to stick with us for quite some time. As such, an important challenge is what can we do to mitigate their potential with respect to global warming. One way we potentially do this would be to retrofit these plants in such a way that we could capture the CO2 that's being emitted.
So again, hitting all the points, right? A subject that's everyone's interested, a question, a problem. I'm interested, I'm intrigued, I want to hear more about this. Where's he going with this? What am I going to learn about it? How's it going to help me understand more about energy and coal and global warming and that sort of thing. So I'm sucked into this one.
Hi, I'm Joe Subotnick, and I'm interested in how we lose energy, not how we use energy. What do I mean by lose energy? Well, everybody knows that we use energy. Just flip on your light switch, turn on your lamp, watch the glow, pay your electric bill later. You know you used energy. But what happened to that energy? There's a lot of energy in the world. Where did it all go? My research interests are understanding how all the atoms in your wall and all the molecules attached to your wall, how they're all jiggling now just because you turned on your lamp.
What happened to that energy? I don't know. I'm not going to watch this. The thing about these 4 videos, too, is they're not the most highly produced videos. These days, people want a personal connection with who's on the video. They want to get a sense that you're talking directly to them. They don't care that the production values are super high. But they care about the information and about the subject and about the inspirational nature of it. One production value that is critical, absolutely important, and it's counterintuitive, that for video, your audio has to be good. And a lot of times you see videos that you can't hear properly. You can't hear what they're saying. And if you can't hear what they're saying, it's not going to work. You need to get your microphone close to the subject. The closer you can get it to the subject, the clearer it's going to be. So this microphone is 6 inches from my face. If you can do that, that's really good. Problem is that a lot of video cameras, the mic is on the video camera. Now the video camera is 10 feet away from the person. 10 feet is a long way. not very good sound. So that's why you always see professional news crew with the big booms, and the boom operator is getting that mic as close to the person's mouth as possible without actually being in the frame. The other way of doing it is getting a cheap lavalier mic like this. It doesn't have to be wireless. It can be plugged into the camera. Get that in, get that close. It's going to work for you. Audio is fairly simple, but it's really easy to get wrong, and it's the one thing that most amateurs, when they're recording video, get wrong. So that's it for me. We'll have Steve come up.
There are a lot of things that go into making a great video. Lighting, sound, camera work, music, animations, performance, all kinds of things that affect how the video is going to be received. But I want to put all those things aside, because we could talk about all these things for hours, and focus on just the most important thing of all, which is how to tell a story about your research that will appeal to the public. I think all scientists tend to fall back on jargon in describing their research. And that's fine when you're giving a poster session to other people in your field, when they understand what you're talking about. But if you're trying to relate your science to the public, to people who are not scientists, you really have to think hard about how to fashion the story to make it understandable and interesting. And it raises the first point, I think, that's important to keep in mind when you're trying to tell a story. You have to use language that is understandable to the people you're trying to reach. The public doesn't understand much about science, so you really have to help them along. Here's an example of how one of you tackled that particular challenge.
Hi, my name is Nate Romero. In the Nasevich lab, we make organic molecules, and our approach to doing this is called photoredox catalysis, which is just a fancy way of saying that we use light to make cool molecules. Now, to understand how we're able to do this, let's break down the word photoredox catalysis.
While he keeps talking, I'm going to say a few things about this. There are a couple of things I like about this video. One is that the scientist involved decided to let his graduate students tell the story, which I think is a good idea, particularly if you think one of the audiences for these videos is potential graduate students. Because graduate students are going to like seeing other people their own age describing the science in ways they can understand. The second thing I like about it is that this scientist understood that if he was going to talk about this particular process, he needed to explain it. He couldn't just throw the term out there and expect the people to understand it. I would encourage you to be even simpler. Maybe leave out that term altogether and just describe it as he initially did, using light to make cool molecules by adding and subtracting electrons, and not use the term photoredox catalysis at all. Scientific jargon is very off-putting to people who don't understand it. So every time you introduce a word or a phrase that the audience doesn't understand, particularly if you don't take the time to define it, you lose viewers. So before you include a complex term like that, ask yourself, do I really need it? Can I explain this to an audience without using a term like that? And if you can, that's probably a better way to go. One of the memorable lines from Henry David Thoreau's Walden is, simplify, simplify, with an exclamation point. He was talking about lifestyle, but it's a rule that applies to chemical communication too. You just need to simplify it as much as you can if you're trying to reach an audience beyond your fellow scientists. Another tool that is very useful in simplifying is analogy. Gino showed a good example from Gary Paddy's video, likening chemical pathways to Google Maps. That's a nice image. It's a way of understanding his science in a way that's not too difficult for an ordinary audience. And here are three other nice examples of teacher scholars who used analogy in explaining their science.
One important aspect of this work is determining what we call the substrate scope. You could think of this like taking our reaction for a test drive. We want to learn how fast it goes. Can it go forward and reverse, handle bumps and curves?
And at the core of these organic molecules are carbon-carbon bonds. I like to think about those carbon-carbon bonds as the brick and mortar of organic molecules. So envision, if you will, a reinforced concrete wall. My mind immediately goes to an elementary school gymnasium. So you can paint those walls, you can decorate it, you can change the appearance, but if you'd really like to make a structural change to that wall, you might as well knock it down and start over. Okay, organic molecules are much the same. We can change various aspects of them and perhaps some reactivity, but if we want to change that basic core of that molecule, the carbon-carbon bonds, it's essentially impossible. If we want to make something like that, instead what we have to do is build it from the ground up.
In this experiment, we use a nanotip electrode, approximately 50 billionths of a meter in diameter, to probe both the topography, the hills and valleys of the samples we're looking at, sort of like a blind man tapping, while simultaneously probing the electrical properties, how the electrons move, and the catalytic activity, how good of a catalyst it is for the reaction we're studying.
Okay, so test drive, a gymnasium wall, and a blind man tapping, all very vivid images that help connect everyday life with the science that's being described. So analogy is a hugely important tool to use in explaining science to a non-scientific audience. But analogies and simple language aren't enough. They're a good start, but you also have to think about story structure. It's important to tell your story in the right order. A lot of you began your videos by, as Gino said, by introducing yourselves, explaining your science in a way that was often a little too complicated, and then only toward the end did you say, well, this is how this is going to be useful in everyday life, or this is how it relates to you. The risk in doing that is that you'll lose your viewers before you get to the end of the video and describe why it's important to them. So a better way of doing it is to begin with something, as Gino said, that intrigues the viewers. Those first 3 seconds, or the first 10 or 15 seconds anyway, are critically important. So start with something intriguing and then explain how your research bears on that. Another way to start off your videos in a way that's effective is to link your research to everyday experience. And here's a good example of that.
Specifically, what we've been interested in lately is actually trying to build molecular versions of cylinders. If you think about it, in the macroscopic world, there's cylinders everywhere. Like if you build a building, there's going to be cylinders in it. And in a microscopic world, in biology, there's cylinders everywhere, for instance, in an ion channel. But as a chemist, it's kind of interesting to try to think of how would you construct one out of atoms.
Okay, so cylinders are things that everybody knows about. We encounter them every day. So what he's talking about is he's trying to create special kinds of cylinders at the microscopic level. Already, I understand what he's talking about. I'm intrigued to find out more about his research. That's a good way to begin. Here's another example of someone who linked her research to everyday experience.
I'm Sarah Skrabelak, and my research group works in the area of nanoscience and nanotechnology. I think people recognize that we provide reliable routes to high-quality nanomaterials, and more fundamentally, a way to think about the synthesis of nanomaterials. So this is not a new phenomenon. In fact, artists have been using this property of metal nanoparticles for centuries in their stained glass windows. But of course, they didn't know that that's what they were doing, and now scientists are trying to engineer specific optical properties into their nanomaterials through unique chemistry.
Okay. So what I like about that particular video is the stained glass windows. That's a really interesting idea that, that people have been using nanomaterials and nanoparticles to impart color to various things for hundreds or thousands of years. One of the, I think, flaws in some of your videos is that when you got around to talking about the applications, you listed some 3, 4, 5 different ways that your research might be relevant to everyday life, but you didn't talk about any one of them in any detail. So rather than give lots of examples of how your research might be relevant, it's better in a video, especially a short video, to focus on one and tell us a little bit more about it. Here's an example of someone who did that.
So if you are able, for instance, to make an air conditioner that functions at even 80% of the energy consumption that current air conditioners do, you would have an absolutely enormous impact. This would probably have the largest impact of any of our research.
So, again, he's relating his research to everyday experience. Everybody knows about air conditioners. They know they use a lot of energy. And you can imagine how if you could re-engineer air conditioners all over the world to use 20% less energy than they do now using his research, that would be a very important thing. Some of the videos were professionally produced. Here's a good example of that. I think it has some very important lessons for us. So let me just play a few seconds of this. All right. So great, nice music, beautifully lit, nice pan.
Researchers in the Pressure Lab in the School of Physical Sciences at the University of California, Irvine are guided by an empirical truth that seeing is believing.
This is, in terms of production value, it's much higher than almost all the other videos that were submitted. It looks great. You could put it on television in terms of the way it looks. But watch what happens next. This is really interesting.
Everyone is familiar with fireflies, which are organisms that use chemistry to produce light. This process is known as bioluminescence. We are harnessing these chemistries, creating bioluminescent imaging probes to look at cells and their movements in tissues and live organisms.
She's talking about fireflies, which everybody knows about. And there's something else that's really interesting there. Look at her face. She's smiling. This is a scientist who is clearly passionate about her research. She really loves what she's doing. And that's coming across in this video. All right, to sum up, when you make videos for the public, keep Henry Thoreau's adage in mind. Simplify, simplify. Beware of scientific jargon. If you must introduce a chemical term, take the time to explain it. Better still, leave it out. Find a way to explain the science that doesn't require introducing lots of technical terms that the audience doesn't understand. Use analogies to make your subject more appropriate. Start with something inviting, a mystery, a problem that needs to be solved, an opportunity that you want to take advantage of, a link to everyday experience. If your university PR or AV department wants to help you make these videos, great. But keep in mind that high-value video production won't make a good video. What you need to do ultimately is tell a story, and that is up to you. And don't forget that you're your own best advocate. Let your enthusiasm for your work shine through and put it to work for you. That's all I have to say, but Gino and I will be happy to answer your questions if you have any.